To solve this question, we need to identify the patterns of logic that are affecting our elements from left to right. How are the elements changing from left to right? Then we can apply that pattern of logic to our last element to find our missing element. The first pattern of logic has to do with the color of the arrows. In our first element, we have 2 black arrows, then we have 1 white, 1 black, then we go back to 2 black arrows and back to 1 black, 1 white. So we're alternating between all black and a black and a white as we go from left to right in this matrix. So that means that our next element, the missing element, should have 2 black arrows since the previous one had 1 white and 1 black. This means that we can eliminate any answer choices that don't have 2 black arrows, meaning answer choice B, D, and E. The next pattern has to do with the placement of the arrows. The arrows are moving around. If we almost imagine this like a clock, they are moving around the clock in a clockwise fashion. This arrow moves to be in this pi wedge here. This moves 1 space clockwise to be in this pi wedge here. Then the same thing happens again. We move this arrow here, and that's how we get this element. And again, this arrow moves here. We're going 1 clockwise pi wedge over, and we're getting the next element. So that means that the placement of the arrows should follow this pattern. We move this arrow to be right here, and we move this arrow to be right here. This would match answer choice C, our correct answer.